So we are all good to go for this lecture, right? And very good morning. This is the Pinder Singh Virk, your Java's teacher, and as of today, we are going to talk about a lot of methods, constructors, and the various kind of priorities of a thread, right? And also the various kind of process synchronization method or the multi-threading synchronization methods that Java offers in order to line up the threads to attack or to access a shared variable or a shared object, right? So let me share my screen first of all with you all. Okay, right. So we're all set to go, and well, I already made a PPT by myself, right, for this lecture, and although I do have a PPT for you for today, the topic number 3 and topic number 4. So this is our main concern for today. We are going to talk about a lot of methods related to the multi-threading, right? And the various kind of constructors that the multi-threading use, and the various kind of priorities that how to prioritize a thread, how to make a thread a low priority thread or a high priority thread, right? How to make a particular thread run first than any other thread, right? So this is all about priorities, right? So I have already made a lot of content by myself, yeah, for by myself yesterday for you regarding these all kind of topics, and we are going to discuss one by one, and also it involves a lot of programming for today. So we will do a programming regarding the process and a thread synchronization, that how to line up a thread one after another if the threads are sharing a piece of code or a piece of statements, right, or any object or variable, right, at one time. So this is all about synchronization. So okay, so we will discuss each and everything one by one. Okay, so I hope that you're all clear with the beginning of multi-threading that we discussed yesterday, that how to create a thread, the number of ways to generate the various kind of threads, right? The first was the runnable method, I'm sorry, the runnable interface, and the second was by making use of anonymous class, and the third was by making use of the different kind of classes other than your main class, right? And we also came to know that what are the various benefits of use of the multi-threading, and what are the various losses or cons if we do not use multi-threading, right? So as you can see on this I mean display, this is nothing but just a life cycle of a thread that I demonstrated you yesterday, and so this is actually another I mean chart or a diagram for the same life cycle, right? So okay, I want you to tell me that am I clearly audible to you? Am I clearly audible to you?
Yes, sir.
Okay, thank you. And is my display I mean, is it able to display to you? I mean, is my display visible to you?
Yes, sir.
Right. Okay, so this is the another life cycle of a thread, right? I mean, these all kind of diagrams are one and the same thing, right? And so one can refer any kind of diagram in order to understand the life cycle of a thread for the interview purposes, right? So this is actually a kind of representation of a thread and a process inside an operating system. I mean to say that whenever we boot up our Android operating system or iOS or Linux or Windows, right? So this is how the processes looks like in our operating system, right? And so here, as you can see that there is process 3 which has created only one thread, and we do have process 1 which has created 3 threads, and all 3 threads are communicating with each other, right? So I mean this kind of scenario is actually being demonstrated very vividly over here, right? And so these are the methods that we are going to cover as for today, and we are already done with start method and run method. As far as start is concerned, start method is actually used by us to run a thread or to run multiple threads simultaneously, right? When we make use of a start method and when we are going to run more than one thread, then all the threads will be run at the same time on the different stacks, right? Please be informed and kindly note that when we make use of start method in order to run multiple threads, all threads run at the same time on different stacks. I mean to say that on different RAM spaces, right? So this is why they can run concurrently. So on the other hand, if we talk about the run method, if we make use of run method to run multiple threads at the same time, then all the threads will run but one by one, because all the threads will run on one stack only. I mean to say that there is only one space to run for them, right? स्टार्ट में क्या था कि जब हम स्टार्ट के साथ मल्टीपल थ्रेड्स को ट्रिगर करते हैं तो उनके पास अपनी अपनी स्पेस होती है रन करने के लिए, ठीक है. दे आर फ्री टू रन इन देयर ओन स्पेस व्हेन they have been triggered by making use of the start method. But on the other hand, when they are triggered by making use of the run method, they only and only have to run in a single space. I mean to say that they have to share a particular space. This is a concept of shared memory, right? So they have to share only a one address space or a one memory area of your random access memory, right? So this is why by making use of run method, this is the main reason why after terminating one thread, the second thread can only start, right? So this is the basic difference between start and run. So you are already familiar with this sleep method, right? Please be informed and be noted that this sleep method demands for the exceptional handling. So you have to surround this sleep method in try and catch, right? So it takes an argument into time. So you can provide a time in milliseconds, right? So 1000 milliseconds are equal to 1 second. So the as time that you want, you can supply the milliseconds in form of integer number to this method, and it will give you that much of time, right? So this is the current thread method. It actually return the current instance of of the current thread. I mean to say that for an example, right now, if ABC thread is running, then this method will tell about the instance, or you can say that about the reference of the current thread, that this particular unique ID or the unique reference of thread is currently being executed in your operating system, right? And this current thread can also return a lot of things related to the thread, right? For an example, the name of the thread, the ID of the thread, and many more things, right? Okay. Next method is actually the join method. So join method has two varieties. The first method is the void method. It doesn't contain any parameter, any parameter, right? And the second join method contains the time in milliseconds, right? So what is a join method, right? When when you make use of a join method with a particular thread, then join by making use of a join method, the thread will wait for itself to die. I mean to say that for an example, if there are two threads, T1 and T2, then T2 will run only and only if T1 terminates. Are you getting my point? If you make use of a join method, I'm repeating again, if you are using join method, then the thread 2, which is scheduled to be executed, it will wait for thread 1 to get terminated, and after only that it can be executed, and after only that it is allowed to be run. T2 can only run after the termination of T1 if you have used join method, right? So join method enforces a particular thread to wait for the prior or the previous thread which is being executed as of now to get terminated, right? Set name function actually sets a name of a particular thread. By default, operating system assigns some name to a particular thread by itself, but you can modify the name. You can give your thread any kind of name as you want. For an example, your own name, your car's name, your house name, right, or your application's name, any actor's name, Shah Rukh Khan, Salman Khan, whatever else, right? So this string parameter, the set name function accepts the string parameter in order to set the name of the thread, right? And the next method is set priority. Okay, so please be informed that I think you must have heard about the priority scheduling inside the operating system if you have studied about the operating system subject. So the operating system actually makes the various kind of schedulings at different times for different types of processes and threads. For an example, an operating system can make use of first come first serve scheduling. It can make use of the priority scheduling. It can make use of the round robin or time slicing scheduling, right? It can be anything, right? It actually totally depends on your operating system that how it schedule the threads or the processes in the ready queue from the disk, right? And so the set priority, for an example, if we assume that your operating system makes use of the priority scheduling, that how can you prioritize your process or your thread? For an example, if I want to execute four threads, T1, T2, T3, and T4, and if I want the operating system or the scheduler of the operating system to run T4 first or prior than T1, T2, and T3, then I can maximize the priority of T4 thread. I can set the priority of T4 thread to the maximum, right? Or for an example, I do not want the T1 thread to be executed prior to T2, T3, or T4. Or in other words, I want to get the thread 1 executed after T2, T3, and T4. So I can prioritize the T1 thread to a low priority. Fine. So in Java, by default, the priority number, actually, the number of the priority ranges from the number 1 to number 10, right? So the number 1 is the low priority and the number 10 is the high priority, right? And by default, for an example, if we are using four threads in our Java program, so by default, your Java sets the default priority for all threads equal to number 5, right? आपने आपने T1, T2, T3 और T4 थ्रेड्स अपने जावा के प्रोग्राम में यूज किए हैं, ठीक है? आपने कोई भी प्रायोरिटी सेट नहीं की है, fine. You have used 4 or 3 threads inside your Java program, and you have not set any kind of priority number to any kind of thread. Then by default, every thread will carry the priority number that is equal to 5. This is the default priority, right? So the 5 is a default priority, but you can modify the priority of a specific thread according to you. Fine. If you want your thread to be a low priority thread or to be a high priority thread, right? Okay. So the next is the daemon thread, right? So I will explain you about the daemon thread in detail on the upcoming pages, but as of now, I only just want to say that when you create any process, or for an example, when operating system sense that the user process has been generated, then it actually generates its own thread. Operating system actually generates its own thread to support the tasks of a user process or a user thread. This is known as the daemon thread. A thread generated by an operating system to support the user's process or the user's task or the user's thread is known as daemon thread, right? Daemon thread is equal to the operating system's thread, not a user's thread, right? But anyhow, you can make your own thread as a daemon thread, right? You can hand over your own thread to an operating system to set that particular thread as a daemon thread, right? However, on the other hand, the daemon thread's priority is very low, and the life cycle of the daemon thread totally depends on the life cycle of the user's thread, right? For an example, if you terminate your user thread, right, then the daemon thread will be automatically terminated by an operating system, right? The daemon thread cannot be exist. I mean, the daemon thread cannot get its existence or it cannot survive in an operating system if its user thread is already terminated, right? So the operating system will automatically and immediately terminate the daemon thread as soon as user terminates its own thread, right? Okay, so there are the two functions related to the daemon thread, right? So by making use of the isDaemon function, you can check whether this thread is a daemon thread or not a daemon thread, right? Or you can set a particular thread as a daemon thread. Please be informed that whatever function you are looking at, if this function is starting with is, then it means that this function will 100% return a value as a Boolean value. It could be either true or false, right? Okay, is alive, again, a Boolean returnable function, right? It will return a Boolean variable. It will return either true or false, right? So is alive function actually informs a user that whether or not the current thread is alive in operating system or is already terminated, right? Okay, get name, right? So you can actually get to know about the name of a particular thread that was actually previously set by an operating system, right? If you have already given some name to a thread, then there is no use to get the name of the thread because you already know about that. But if in case you have not assigned any kind of name to your thread, then you can read the name or you can get the name of the particular specific thread by making use of the get name function, and get name function returns the name in form of string, right? Okay, so the next is int get priority. You can get to know about the priority of the currently executed thread or the current thread, right? You can get to know that, okay, I want to know that what is the priority of T1 or T2 or T3. So I can simply write that system.out.println T3.getPriority, and you will get to know that, okay, so this is the number that was previously assigned to my thread, right? So it can return a default priority if you have not prioritized your thread prior, right? Or it can return it can return any of the numbers ranges from 1 to 10, right? Okay, int get id, right? So if you make use of this function, then it will return the id number of a particular thread that is assigned by an operating system to a thread, right? I already informed you and I already taught you that whenever a process becomes active in a ready queue, or whenever an operating system gets a process from a disk to a random access memory or in a ready queue, the operating system actually assigns a unique ID to a process. So in the same way, whenever you create a thread, then the thread will also be assigned with a unique ID, right? As you all have the unique roll numbers, right? So every unique process inside our operating system and every unique thread inside our operating system is assigned with the unique ID, right? And this is known as the process ID or the thread ID. Okay, so please, I want to check that whether or not I have turned on the recording. Yes, this is turned on. Okay, right. Resume. The further functions are suspend. You can suspend your thread for a specific time, right? And you can resume your thread if you have already suspended it, right? And the stop function actually stops your thread, right? Destroy function actually terminates your thread, right? And is daemon. So is daemon function actually returns a boolean value, and it tells you that if the current thread is daemon or the user's thread, right? Okay, toString function is actually returns something, some information related to a thread in form of string, right? In form of characters. So for an example, if you want to return, if you want to read ID or any kind of integer information such as priority of a thread in form of string, then you can make use of toString function, right? And please note that the suspend function, resume function, and stop functions, these are deprecated or no longer supported by the owner of Java. Who is the owner of Java? The owner of Java is Oracle, right? And before Oracle, the owner of Java was Sun Microsystems, right? So it could be a question of the interview. So आपको आपको पता होना चाहिए. You must have informed or you must have a knowledge about each and every a small piece of information related to Java before going to the interview, right? Okay. So please be informed that the suspend, resume, and stop functions are no longer supported by the latest version of JDK and JVM, right? Okay, okay. यहाँ तक किसी को भी confusion है? Do you have any kind of query or any kind of question till now? Okay, so my mic is making a noise. Okay, I have adjusted it. So am I clearly audible to you? Is it okay now? Yes, Vinay? Okay, am I clearly audible to you? Is it okay now?
Yes, sir.
Okay, perfectly fine. Okay, so we can now approach to the various kind of constructors of a particular thread, right? So I think you already must have a knowledge about the constructor, that what is a constructor if you have already studied C++ or if you have already studied Java, right? Then the constructor is actually a kind of method with the same name of a class. I mean to say that the name of this method, I mean to say that the name of the constructor must match with the name of its class. हमने हमने कल एक constructor बनाया था. We made a constructor yesterday, right? To take ourselves out of the static field in order to deal with a keyword that cannot be run, or that cannot be executed in a static field, right? So you want to say something? I think uh, someone has unmuted his mic. Do you want to say? Okay, right. So there are the various basic rules of a constructor that you must have already known to, right? If you have studied C++ and Java. So there are four types of constructors in a thread, right? So you are able to see over here on my screen that the first constructor is a thread with no parameters. So this is the non-parameterized constructor or a default constructor, right? I am recalling the constructor again if you have not studied the constructors, or if you have studied but you do not remember about the constructors now, right? So this is the constructor of a thread. with a parameter of string, right? So you can pass the name of a particular thread using this constructor, right? Or the third number is runable, or you can actually pass some object of a runable to your thread. Yesterday we passed this keyword in the constructor of a thread, right? To inform the thread class that our thread work will be executed in our main class only, right? I mean to say that the public void run or the engine of the thread is actually located in our main class, right? So if you remember, we already done this yesterday, right? We passed this as an object of the runnable inside the constructor of a thread. And also, I think we already set it the name of the thread yesterday. If not, then we can do it, I mean, as of today, right? Or in the fourth option, you can pass runnable R. I mean, any kind of instance of a class or object of a class, and side by side, you can also pass the name of the thread, the specific name that actually you want to set for a specific thread, right? Okay, so these are the four constructors that we have discussed. So there is always a thread scheduler, right? As operating system has a process a scheduler to schedule a process, right? So in for the thread scheduling, the operating system has a thread scheduler, right? So what is the job of a thread scheduler? The thread scheduler actually gets a particular ID of a thread from a process, and it schedules a thread into a ready queue to inform the CPU that there is some thread which is actually in a runable state and waiting for you, or waiting for CPU to execute to get executed, right? So it decides which thread should run, right? So please note, note at this point that for an example, if you have not prioritized your thread, and if you are running more than two threads at the same time, then the thread scheduler can randomly run your thread according to its choice of scheduling, right? For an example, I am running T1, T2, T3, and T4, and I have not prioritized any of the thread, right? Assume that T1, T2, T3, and T4 have the same priorities or the default priorities or equal priorities, right? So in this case, the thread scheduler will randomly select any of these four threads, and it can schedule these threads one after another by making use of its own choice of scheduling algorithm, right? So as you can see that it mostly schedules the threads in a ready queue by either using preemptive scheduling, right, or a time slicing, right? So time slicing is actually a round robin scheduling. Each and every process or each and every thread is only allowed to get executed in a predefined time slice, right? Or a CPU will only remain at a specific process or a specific thread for a certain amount of time. And this is all about a round robin scheduling, whereas the preemptive scheduling can be applied to a priority scheduling, or it can be applied to a first come first serve scheduling, or it can be applied to a shortest job first scheduling, right? So what is actually a meaning of a preemptive scheduling, right? So for an example, if I have T1, T2, T3, and T4 thread, right? And if I have prioritized T3 thread, I want T3 thread to run prior to T1, T2, and T4. Then my thread scheduler will make use of the preemptive scheduling or priority scheduling to prioritize my T3 thread, right? And it will schedule the T3 thread first, and then after T1, T2, and T4, right? Okay. So this was all about a thread scheduling or thread scheduler algorithm, right? And the next thing is a difference between time slicing and preemptive scheduling. Okay, so we are already familiar with this. I have just explained the basic difference between the time slicing and a preemptive scheduling. Can we start a thread twice? No, you cannot. Fine. So for an example, you want to start T1, right? So you have specified T1 dot start, and again you return T1 dot start. Okay, your thread will start at first, right? But when it will again face the same line like T1 dot start, then it will throw an exception, right? And your program will be terminated forcefully by an operating system with an exception, that illegal state of exception. So it means that this is actually not a good programming practice to start a thread twice, right? So you should know that whether or not a particular thread is running or is alive in an operating system already or not. If it is alive already in an operating system, it means that it has already been started previously, so you cannot start it again. Otherwise, you will get an error and your program will be forcefully terminated, which will not be a good user experience, right? Okay, so you cannot state a start function two times for a single thread, right? Okay, so what is the difference between triggering a thread with a start and a run method? I think we are very clear about this concept, right? I mean, what actually happens in background or in operating system when we actually start multiple threads with the start method, and what happens actually when we actually start the multiple steps, the multiple threads with the run method, right? Okay, so we are quite familiar with all these kind of topics related to the multi-threading, right? So you are good to go about the theoretical concepts as far as your interview is concerned, right? Or as far as your Viva is concerned. So okay, so here we go. Here we are going to begin with a little programming about the various concepts of the various kind of functions related to the threads. I mean the various important functions of the threads that actually we generally use when we make use of the multi-threading in Java, right? So the first is the join method. So we already made use of start function. We already made use of the run method, right? So it's time to make use of the join method, right? Okay, so please, I just want to see that if there is any other message. No, there is no message, right? So, do you have any question till now? Do you have any query till now? Any response from your side? Okay, I am assuming that you're all clear with the current concepts, right? So let's talk about the join method. So the join method, so this is an explanation of the join method, right? The join method waits for a thread to die. I mean to say that if you are going to run T1 and T2, right, and the T2 will wait for T1 to die or to get terminated, only then the T2 will run. Otherwise, the T2 will be in a waiting state, right? It cannot get the CPU's attention until and unless the T1 actually dies or terminates, right? So जब तक T1 terminate नहीं हो जाता, T2 नहीं चलेगा. So this is actually a magic of a join method, right? So this is a small code of a join method related to the join method. So what I'm going to do, I'm just going to copy and paste this code. I already made a lot of codes for you as a homework of mine for today's class. So it will save a lot of time of us. So I'm just going to copy and paste this code into the Eclipse editor, so that we could run this code. I think there is a problem getting this code from the PDF. So what I'm going to do, I'm just going to open the Microsoft Word representation of the same PPT, and from here I think this will be damn easy to pick a code and place into the Eclipse. Right, so here we go. So we do have a code over here. So what we are going to do, we are going to simply copy and paste it from the IDE and paste it into the Eclipse IDE. So here you are, right? So I'm just going to explain this code, right? So we do have a test class over here, right? And this test class actually extending a thread. I mean to say that um, we are about to run a thread in this test class, right? So so let us begin with the main function of the test class, which is actually a parent class. So test class is our parent class. So test class is actually going to trigger 4 different threads, right? As you can see that test T1, T2, new test, right? So uh, T1 dot start. So here uh, we have already started T1, right? And then please be informed that whenever you will use join method, the join method actually demands for try and catch or exception handling. So you have to surround join method in a try and catch in order to make it possible to run. Otherwise, it will be a syntactical error, right? So we have started our thread 1, and we actually assigned a join method or associated a join method with T1, right? So this method will actually inform the next thread that the current thread do not want the next thread to run while it is running or until it terminates, right? So here on the next line, we started the next thread, right? And uh, we use the same thing or same function with T2, right? So T2, so now T1 has informed T2 and T3 and T4 that you are not allowed to run until I am running, right? Or it is saying T1 is actually saying over here that T2, T3, and T4, you cannot execute yourself or you cannot get CPU's attention because I am running, right? So wait for me to die or wait for me to get terminated, right? And on in the same way, T2 is actually informing T3 and T4 that hey, T3 and T4, I am currently running and you are not allowed to run while I am running. So this is all about join method, right? So here we have not made use of any kind of milliseconds into the join method, right? So in next program, I will also demonstrate the use of the milliseconds into the join method, right? So what I'm going to do, I'm going to run this code, right? And before running this code, let us I want to explain you this code, right? So this code is actually associated with the thread functionality, right? So this is the public void run method. As I already informed you that the run method is actually a machine or an engine of a thread. Without run method, your thread cannot run your statements, right? So here we do have a for loop that actually starts from 100 and ends on 106, right? So on printing, we will get 100 to 105, right? And we made use of a thread.sleep for half of a second so that we could observe the results in an efficient way, right? So in this statement, we actually displayed the iteration number of the k of for loop, right? So when so I'm going to this for loop will be used by T1, T2, T3, and T4, right? One after another or parallelly, right? So I'm just going to run this code and it will clear each and everything to you, right? So it's 100. So you can see. So let us wait for this execution to get finished. So okay, so this is time to explain you the output. So 100, 100, 200, I'm sorry, 100, 101, 2, 3, 4, and 5, right? So this is actually an output of T1, right? I'm repeating, from this 100 to this 105, this is an output of T1, right? And at that specific time, the T1 was only running, and T2, T3, and T4 were actually waiting for T1 to get finished. Okay, so next output. 100, 101, 102, 3, 4, and 5. Actually, this output is associated with T2 thread, right? So while T2 was running, T3 and T4 were actually waiting for T2 to die, right? So T3 and T4 were not able to run because T2 was executing at this specific time, right? Okay, so here we go. So this is the output, right? So here you can see that this 100 is associated with T3 and T4, T3, T4, right? T3, T4, right? Up to T105, T3 and T4, right? So here, because T1 and T2 are finished now, so T3 and T4 can parallelly execute their tasks at their different spaces or at their different stacks, right? So they were actually waiting for T1 and T2 to get finished. Okay, so T1, as soon as T1 and T2 gets terminated, the T3 and T4 had actually executed their work as soon as possible, right? So immediately they started their work. So this is the output of T3 and T4. So are you clear? Is that concept clear? Do I need to repeat it again? Karthike, you have sent yes. So is that yes for clear or a repetition? Are you clear for this? Right, right. So I assume that this code is actually clear to all of you fellows, right? So I'm just going to copy and paste this code to the chat, right? So that you can try this code later on after the meeting or after the class, right? And I will also share the notepad files of the code that I made for you. Or I think there is no need to share over here because I'm going to share this Microsoft Word file or this PPT file with you all, so you can directly copy and paste these codes from this Microsoft Word file to your preferred editor, right? So this is the join method with the milliseconds, right? There is no any huge difference between this code and this code, right? All I am going to write some time inside a join method, right? So for a specific time, a particular thread can actually prevent some other thread to wait, right? And after that particular time, that particular thread will not be able to prevent or stop some other thread to wait for its termination, right? So let us copy and paste this code into the editor, and I will explain you this code. This code is exactly same as the previous code that I explained already, but with a small modification, and this modification is actually over here, right? So this is the same code, right? The public void run is actually the same, right? And this time we actually do have three threads: T1, T2, and T3, right? Okay, so we started T1, right? And we made use of a join method, and in this join method we actually made a pause for 1 second or 1000 millisecond. I mean to say that the T1 actually saying T2 and T3 that, hey, to T2 and T3, please do not run for at least 1 second because I am going to run, right? So T1 has already given a specific time to T2 and T3 to wait for it right? And after so now T2 and T3 will only pause or will only wait for T1's execution for only 1 second, and after that they will not care for T1, right? They will start their work as soon as this time will elapse, right? So what I'm going to do, I'm just going to run this code, right? So here we go. So you can see the changes, right? Okay, so let me explain you the output. So the first thing is this 100 actually belongs to T1. 101 belongs to T1. 102 belongs to T1. Okay, so now here, after that, the changes are actually reflecting into the output. So here यहाँ तक 1 second खत्म हो गया था. Fine. So here 100 milliseconds were elapsed. So as soon as 1 second was elapsed, T2 and T3 had resumed their work. They got triggered and they were active and they started their work, right? So this 100 is actually related to T2. This is related to T3. Okay, T1, T2, T3, T1, T2, T3, right? And and so on, right? So when you will run this code by yourself, you can carefully examine the output of that particular code, right? So we made use of a time in form of milliseconds in a join method, right? So the join method actually is overloaded. I mean, this is all about the function overloading, right? So the join method can be used without any parameter, or you can pass a little amount of time according to your choice into a join method, right? So the join method in a thread is actually overloaded method, right? Okay, so the next concept is the priority of a thread, right? So in some cases, sometimes we need to prioritize a thread. So this is all about the thread priority, right? And I want to show you something, right? And that how Microsoft Windows prioritize its processes, right? If I think we need to open the priority. We need to open the properties. Uh, I I'm right clicking over here, but I'm not actually able to see the properties option over here. It was actually able in I mean it was available over here as far as Windows 7 or Windows 8 is concerned, but this is Windows 10 and I'm not very much familiar with Windows 10, so I'm not actually able to find the properties. Yeah. Well, we should open the task manager. So actually, yeah, okay. So this is inside the task manager, right? And the more details. So here, somewhere here, it will show you the priority of a particular process. You can actually set the priority, right? So performance and app history. I was actually able to set the priority of a particular process by making use of the task manager, but I'm astonished that over here in Windows 10, everything is actually quite different than Windows 7 and Windows 8. Let me check the properties of that particular process, right? Okay, and that whether or not I will be able to prioritize this process inside the Windows 10 or not. No, I think we need to export it on on the YouTube, that how to prioritize the process inside the Windows 10. Although I was very clear as far as Windows 8 and Windows 7 is concerned, right? So yes, by making use of Task Manager, right? As far as Windows 7 or Windows 8 is concerned, you were able to prioritize your process, right, over the other processes, but over here I'm not actually able to find that particular option. So okay, I will inform you after exploring this option after this class, and I will let you know that how you can prioritize your particular process inside Windows 10, right? Okay, so let's get back to the lecture, right? And here we can prioritize the Java thread, right? And each thread has its own priority, right? As each process has its own priority, right? So the priority representation is always in the range of 1 to 10, right, in Java. Right. So in most cases, the thread scheduler actually schedules the various threads according to its own choice, provided that if you have not setted any kind of priority to any kind of thread, then the thread scheduler will schedule your threads in a ready queue according to its own choice of scheduling algorithm, right? And if you have already uh, setted any kind of priority of any kind of thread, like for an example, if you made any thread to the minimum priority, or if you made any thread to a maximum priority, then according to that, the thread scheduler will pick that particular thread first or last according to its priority, right? So by default, the priority of the threads of Java are at norm priority. So non priority is actually the number 5, right? Whereas the minimum priority is actually the number 1, and on the other hand, the maximum priority is actually the number 10. So you can assign any kind of number, number 2, number 3, number 4, right? Number 1, number 7, blah blah blah, and any kind of number that actually you want to, right? So the norm priority is also known as the default priority in the simple terms, right? So let us work on the priority testing of the thread, right? So I'm just going to copy and paste this code in my Eclipse editor, so that you could able to see that how to set a priority and how priority works in Java, right? So over here, this is my main class or a parent class, and it is going to run the multi-threading, right? So this is the body of the public void run, right? And in this public void run, I simply I mean, didn't anything special. I only written system.out.println, and in the first statement, I written over here that running thread name is this is this, and the system or dot out.println. I mean, this in the second line, I wrote over here that the running thread priority is this, right? So thread dot current thread dot get priority, right? So I read the priority by making use of these functions that we already gone through in our this lecture a few minutes ago, right? And I read the name of the thread by making use of this function, right? Dot get name, and I got an instance of the current thread by making use of dot current thread method, right? Okay, so in my public static void main function, what I did, I attempted to make two threads. I do have the first thread M1 and the second thread M2, right? So by nature, the M1 should be executed first, right? Because I have written it prior to M2, right? And M2 should get executed after M1 because I stated this statement after M1, right? But over here, please see over here, in case of M, I actually minimized its priority. I mean to say that I simply wrote over here that thread dot min priority. So min priority dot max priority and dot norm priority, these are actually the constants, integer constants, whereas the min priority is a constant integer number 1, max priority is constant integer number 10, and the non priority is constant integer number 5, right? Which is actually a default priority, right? So according to these two statements, M2 should be executed first or prior than M1, right? So let us test it. Okay, so see over here, right? So thread one, my the name. So the first line of the output is saying that the name of the firstly executed thread is thread one, right? And the name of the secondly executed thread is thread zero, right? So it means that M1 was thread 0 and M2 was thread 1, right? So these are the names of the threads setted by an operating system, but you can also modify these names anyhow, right? And the and in the third line, right? So this third output line is actually associated with the first line, right? So third line says that the running thread priority of thread 1 is 10, right? Because this is max priority. And the last line is actually related to the second line, right? With thread 0. The last line is actually explaining something about the thread 0 or M1, right? It is saying that the running thread priority is 1, which means that 1 is low priority and 10 is high priority. It means that M2 was prioritized higher than M1. So M2 was scheduled first by the thread scheduler, right? So M2 has got CPU's attention prior to M1, right? So M2 has executed its task before M1. So I hope that the priorities are clear to you. Um, any details? I'm sorry. Any kind of confusion do you have till now? Any kind of confusion do you have till now regarding priorities? If you don't reply in 10 to 15 seconds, then I will automatically assume that you're all clear with with the concept of the priorities. Right. Okay. So Meghanshu, okay, so you told me that I need to right click on details and over there I could find the priorities option in the Microsoft Windows 10. Okay, I will check. Okay, so according to Meghanshu, you have to right click on the details, right? So, okay, thank you, Meghanshu. I'll get back to you with this kind of thing, right? Okay, so the prioritization of a thread is all clear to each and every student. I assume that. So this is all about the daemon thread. What is daemon thread, right? So I already explained to you about the daemon thread that the daemon thread is actually a thread in Java, which is actually a service provider thread that actually provides a service to the user thread, right? Its life depends on a mercy of the user's thread, right? I mean to say that as long as a user thread exists in an operating system, the daemon thread can survive for that specific amount of time only, right? As soon as a user thread dies, the daemon thread will die immediately, right? So this line actually explaining the same thing. When all the user thread dies, the JVM terminates this thread automatically, right? It is a low priority thread, right? It provides a service to the user threads for background supporting tasks, right? For an example, background supporting tasks are the tasks such as, for an example, if the user thread demands for any kind of resource from the operating system, right? So this daemon thread can actually act as an intermediator between an operating system and a user thread, and it can communicate the messages of the user thread to the operating system regarding the demands of the user thread, right? So it has no specific role or a special role in life or in its life cycle than to serve the user threads. And there are the various kind of daemon threads running into the operating systems. Those acts as a garbage collector threads, right? So I think you're already familiar with the garbage collection system. of C++ and Java, right? So I think there is no need to explain about the garbage collection, and this is actually not exactly related to the multi-threading, but garbage collection is something that is actually deletion of the unused objects from your memory, right? So in C or C++, there was not actually an automatic operation to delete the unused object of the classes, right? So one had to manually delete those unused object by making use of the free and delete methods in C and C++. But as far as Java is concerned, on the other hand, the garbage collection system is automatic, right? It automatically generates the thread for the garbage collection. And these kind of daemon threads are generated by the operating system or Java to actually remove the unused objects made by the user to free up the memory uh, for the next available tasks, right? Okay. So this the next topic is synchronization in Java, and this is really a really very important topic while studying an operating system, while studying processes, and while studying the multi-threading, right? So the synchronization is Java is nothing but as in a simple terms lining up your processes or your threads in such a way that each and every thread should attack or should access a particular shared resource one after another, right? So I think if you remember, there was a chapter named synchronization or a process synchronization in your subject of operating system, and that there was actually a book of Galvin Gagne, right? The red colored book of Galvin Gagne, and there was a complete dedicated chapter for the process synchronization, in which there was a lot of details that how to synchronize and process or a thread, or how operating system actually synchronize or line up the various kind of concurrently executing processes or threads in a race to use a shared resource, right? So in basically according to the operating system, synchronization can be implemented as the mutual exclusion, right? There was a concept of the critical section in operating system. There was a concept of your semaphores, right? So if you remember, you can relate your operating system knowledge with this synchronization concept in Java, right? So we are going to implement the synchronization methods or the synchronization implementation programmatically in Java, right? So you're going to see the programmatic, the programming of the synchronization related to the various threads in Java in upcoming session or in the next topics, right? Okay, so the synchronization is mainly used to prevent thread interference, right? So for an example, you do have a single shared resource, right? For an example, ABC. ABC is your resource, or ABC is a kind of, you can say that a variable, right? And there are four worker threads, right? You have generated four threads, right? And the four threads, the requirement of these four threads is to use that particular ABC resource or ABC variable, right? So it means that you are going to share that ABC variable in or among these all four worker threads, T1, T2, T3, and T4, right? So now you do not want these four worker threads to access that particular shared ABC variable or a resource at the same time. ठीक है, आप नहीं चाहते कि एक ही टाइम पे सारे थ्रेड्स जो हैं वो ABC रिसोर्स पे अटैक कर दें या उसको शेयर करने की कोशिश करें, उसको एक्सेस करने की कोशिश करें. You do not want all the worker threads to access that ABC shared resource at same time, right? So you want to line up T1, T2, T3, T4 in such a way that each and every thread can get or can access that particular shared resource at one time, right? Until and unless one particular thread finishes its work with that particular shared resource, the other threads have to wait for that particular thread to finish its task, right? Fine. So अगर अगर आप सिंक्रोनाइजेशन में आपने क्या किया, एक शेयर्ड रिसोर्स है, ठीक है, आपने T1, T2, T3 और T4 को लाइन अप कर दिया, राइट. फॉर एग्जांपल T1 चला गया ABC को यूज करने के लिए, तो जब तक T1 ABC के साथ अपना काम खत्म नहीं कर लेता, T3, T4, T2 और T4 ABC को हाथ नहीं लगा सकते, राइट. Until the ABC does not finishes its I'm sorry, until and unless the T1 does not finishes its work with ABC, T2, T3, T4 cannot touch that particular shared resource if you have applied the synchronization on that particular ABC resource, right? So this was the very basic and very detailed information about the synchronization of of a particular thread or a particular process, right, with respect to the shared resource, right? So there is a concept of lock, right? For an example, if ABC is a resource and if that resource is going to be shared with T1, T2, T3, and T4, then for an example, if T1 has accessed that particular ABC resource prior to T2, T3, and T4, then T1 will apply a lock on that particular ABC resource, right? And that particular lock will be a notification to T2, T3, and T4 that, hey, T3, T3, T2, T3, and T4, I am T1 and currently I am working on ABC, and you are not allowed to enter and you are not allowed to access ABC because I am currently working on it, and you will be allowed when I will be terminated, right? So this will be the message of T1 to T2, T3, and T4, right? Okay, so the types of synchronization, the first type is process synchronization, and the second type is thread synchronization, right? And these are the two types of thread synchronization. The first is actually, um, I mean, um, we can actually apply the synchronization in these two ways. The first is mutual exclusive. So this is all about applying a lock on a particular shared resource, right? And interrelated communication, right? By making use of IPC, inter-process communication, right? So one thread in IPC or in inter-thread communication, one thread actually priorly informs all other threads or notify all other threads that I am going to share that particular resource, so please do not touch that particular resource. But before issuing that particular notification, it firstly checks that whether or not is there any other thread currently working on that particular resource already or not. If there is, then this thread has to wait, otherwise it can get an access to that particular shared resource and it can notify other threads about its access, right? Okay, so we are in this context, and in the Java multi-threading, we are only and only going to discuss about the mutual exclusive, right? So under the mutual exclusive concept, what we are going to do, we are going to talk about the different three distinct methods to apply synchronization on your Java's code, right? Or the piece or a portion of your Java's code, right? So the first is the synchronized method, right? So you can actually, so for an example, we do have we do have we do have three threads, right? T1, T2, and T3, right? And now uh, T1, T2, and T3 wants to access the particular ABC method inside a particular class, right? So you can synchronize this method, which is going to be shared among T1, T2, and T3, right? Okay, so this was all about synchronized method. You can synchronize whole method or whole function, right? And or you can, I mean to say that you can apply some sort of lock on a particular method to make it synchronized, right? Okay, synchronized block. So this is slightly different than the synchronized method, right? So in the synchronized block, we don't actually synchronize the whole method, but we synchronize specific lines of code of your whole program, right? For an example, our method has 100 lines of code, right? Or it has 100 statements inside it, right? And you want to synchronize only statement number 50, 51, and 52. So you can actually, you do not have to synchronize all 100 statements. You do not have to synchronize whole method. You can over here synchronize line number 50, 51, and 52 by making use of synchronized block. I mean to say that you can actually get these three lines into a special block or a specific block that will be designated as with a keyword name synchronized, right? Okay. The third is the static synchronization, right? So in the first method and in the second method, I mean to say that in the synchronized method and in synchronized block, there were some problems, right? And in order to solve those problems, Java offers a static synchronization, right? So we are going to discuss about these all three synchronization methods, one after another in our time till 1:30, till 11:30, right? And so this is the piece of code. So let me tell you, or let me demonstrate you that what kind of the problem that we can face if we do not apply synchronization, and if a particular piece of code, or if the particular method is actually shared among the various threads, right? So this is the piece of code which actually explaining the problem of sharing a resource without synchronization, right? So I'm just going to copy and paste this code into the Eclipse editor so we can run this code, right? Okay, so this is our code. So let me explain this code first, right? So let us start with our main class or the parent class. So the test is our parent class, and it contains the main function public static void main, right? And in this class, we have made an object of another class named table, right? So where's that class? This is the class, right? So this is the class table. So class table has its own functions, right? It has its own piece of code, right? So what we are going to do, we have made an object of a class named table, right? And we have created two different threads, right? My thread 1 T1 is equal to new my thread 1. My thread 2 T2 is equal to new my thread 2. And over here in the constructor of the thread, right, we have passed two things, right, simultaneously. So before explaining about the various kind of the constructors of the thread, I talked about this one, right? So please have a look on this thread runnable R and string string name. So we can pass an object and the name of the thread at the same time. So this is what exactly we are actually doing at this time, right? And over here we have to thread one. We already passed the object of the table class, and with that the name of the object, right? And similarly, in case of second thread, we passed the object of the table class and the name of the second thread. And after that, we triggered both of the threads. We started both of the threads, right? Okay, so let us see what actually is happening into the code of class table and the code of first and the second thread, right? So I think you are clear with the code of the main class, right? So let us talk about the code of the table class, right? So we do have a function named void print table that actually takes two parameters into an account. It accepts actually two parameters. The first parameter is integer parameter, and the second parameter is string parameter, right? So so till now this is not synchronized, right? So I'm deleting this one, right? So till now this is not synchronized, right? So without synchronized example of without synchronization. Okay, right? So this is an example of without synchronization, right? So in that for loop, we are starting with k is equal to 1, and we are ending on k less than equal to 5 and k plus plus, right? So in this for loop, what actually is being happened, the output will be 1, 2, 3, 4, and 5, right? And no, the output will be n multiplied by the iteration number, right? N multiplied by 1, n multiplied by 2, and so on till n multiplied by 5, right? So we are getting the data in that particular n from this parameter, right? So this parameter is actually getting multiplied by the iteration number of the for loop, right? And after that, we made a pause of half of the second, right, to observe the output in a more efficient way, right? And now let us move to the code of the second thread, right? Sorry, the first thread, right? So this is the class myThread1, which is actually extending the thread class as yesterday we are doing over here, right? So here, what I did in the first statement, I made an object of the table class, right? So what we are going to do, we are going to share this function. Please pay an attention over here. I forgot to explain this. We in the class table, we are going to share this function with both of the threads, right? But we have not applied any kind of synchronization, right? So we are going to see the disadvantage of not applying the synchronization if we have shared something with the two threads, right? So okay, so as continuing to explaining the code of the first thread, I have created an object of the table T, right? So this is the table class, and I have created an object over here, right? And I have created a string object, and I initialized it to the blank, right? And my thread one, right? So the my thread one, and this is actually a constructor of this class, right? Right? And in this is the parameterized constructor, and it is actually getting two parameters from the main class, from the test class. What are the two parameters? The first parameter is object, and the second parameter is the thread, right? So here we are getting the object of the class from our main class, and object of the table from the main class, and from here we are actually getting the name of the thread from our main class, right? So this dot t is equal to t. So over here I actually tried to tell interpreter, or to tell CPU that this side of t is actually this t, and this side of t is actually this t, right? So that the interpreter or the CPU uh, could not could not get confused that which T is what, which T is which, right? Who is who. So I actually distincted or I differentiated one T with another T, right? So this dot T is actually belongs to the T that actually is inside the class, right? And this side of T actually belongs to the parameter of a particular function. I think you are already familiar with this kind of thing, right? So I did exactly same with the name, right? So this dot name is actually this variable or this object, and this name is actually this object, right? So the object of the table which is sent by my main class is actually being allocated to this object, right? I mean the reference is being allocated to this object, and the name which was sent by my main class related to the thread is actually being assigned to this object of string, right? And okay, over here, as you can clearly see that in the engine of the thread, we actually simply called the print table function, right? By making use of dot operator, right? T dot T. So T dot print table, right? So when it will be executed, the call will be transferred to this piece of code, right? I think you are already familiar with this thing, right? How to access a particular function of a particular class by making use of a dot operator, right? So in the run function of the first thread, it is actually sending a 50 a number 50 with the thread name, right? So the 50 will be received over here and the name will be received over here, right? So according to that, this for loop will run, and according to that, it will display the result of thread 1. So similarly, exactly same thing is being done in thread 2, right? So here I slightly actually changed this number, right? I changed it from 50 to 100, and it has its own name, right? Thread 2. So let us run this code and let us see what actually happens, because the synchronization is not applied and the print table function is being called by both of the threads. See, the print table function is actually shared among both of the threads, right? So I'm going to run this. See, in the output, the output is mixed. It means that both threads have attacked on the print table function of the table class at the same time. This is the problem, right? It can be a problem of dirty read, it can be a problem of dirty write, right? It can be a producer consumer problem, right? I mean, it can be anything, right? This is not good. I mean to say that if there is one resource, then it should be shared by only and only one thread at a specific time, and the second thread should wait for the first thread to finish its task. But over here in the output, as you can clearly see that both threads are not synchronized, right? They don't care for each other, right? And they don't know about the actions of each other, right? And they have simultaneously accessed the print table function of the table class at the same time. So this was the problem, right? So this was the problem I actually wanted you to see on my screen. So over here, do you have any kind of query or any kind of confusion till now? Do you have any query or any kind of problem till now? Okay, all set. So let us move to the next. So now how to solve this problem? How to solve this, right? How to apply a synchronized way? How to apply a lock on the print table so that if the first thread is actually currently has accessed the print table, so that at that particular time the second thread should wait. how to force a second thread to wait for a first thread to finish its task, how to line up the threads, right? How to actually apply the synchronization on a shared resource, right? So here I am going to copy and paste a code for Java synchronized method, right? I'm just going to talk about the synchronized method, right? And here we go, right? And the code is exactly same as the previous code, right? Nothing changed except only one thing, right? uh, as in the previous code, we have not written any kind of synchronized keyword with the print table function, but over here we have written a synchronized keyword with the print table function, and the print table function is actually being shared with both of the threads, right? As you can clearly see, right? So now this whole function from this to this scope, from here to here, the whole function is now synchronized, right? So if a single thread is working into this function, then no other thread can access to this function at a specific time, right? If a particular thread is actually being executing or is working with this particular function, then other threads will wait for that particular function which is currently executing on print table to get terminated, right? So I'm going to run this code, right? The code is exactly same. I'm repeating. I have just written synchronized keyword over here, and rest of the code is exactly same. So here you can see this is the magic, right? This is the magic of the synchronization, right? So see, I have not given any priority to both of the threads, right? So the thread scheduler has automatically scheduled the thread 2 to be executed first, then and then the thread 1, right? So in this case, the priority was actually default, or the priority was actually equal. So the thread scheduler actually randomly scheduled thread 2 first and then thread first, right? Although we have written thread first, I mean prior to thread 2, right? Okay, so let's get back to the topic, right? So now both threads are synchronized, right? The output is not mixed because the thread 2 was started first, and because the thread 2 had accessed the print table first, right? So only and only thread 2 was able to work with that particular print table function at a specific time, right? Although the thread 1 was also triggered, as you can see over there, right? We have simultaneously triggered both, but because thread 2 was scheduled first and thread 2 had an access to the print table function first or prior to thread 1, so thread 1 had to wait for thread 2 to finish its task, right? So thread 1 was not actually able to start its task because until here the thread 2 was actually working, right? So as soon as thread 2 got terminated, thread 1 began its task, right? As you can see that this is a task of thread 1. So this is the magic of synchronization, and this is how we can apply the synchronization by making use of the synchronized method way in Java to line up one or more threads, right? Okay, the next thing is actually okay. So um, uh, to add on I mean, uh, in the next scenario, this code is exactly this code is also related to synchronized method as we did over here, right? But in this code, but in this code, I actually made an anonymous class of a thread, right? I mean to say that in the previous code, I made the two different classes for two different threads, right? But um, in this code, right, I actually made an anonymous class for both of the threads, right? So in this program we have created the two threads by anonymous class. So less coding is always, I mean, required. So less coding is required if you opt an option to make a thread by making use of an anonymous class method for multi-threading, right? So over here, I will copy and paste this code, right? The explanation of code is quite same as previous code, but with very slight changes, right? So this is exactly same, right? The class table is exactly same, right? The synchronized is exactly same. The this is exactly same, right? And in class test, I actually made two threads anonymously, right? These I implemented two threads by making use of anonymous class, right? So this is the thread one, and this is the thread 2, right? And this is actually the object of the table class, right? I had to make this object final because if you are going to use any kind of a variable or object into the anonymous class, you have to you have to make that particular object or variable final, right? You cannot make unfinal or non-final object or variable in anonymous class, right? It will be a syntactical error, right? Okay, so that this is same. The thread one is actually calling the print table function, and thread two is also calling the print table function. So both threads over here calling the same function, right? So we have already applied the synchronized method function. So let us run this code. See, our both threads were actually synchronized, and also this time the thread 2 was scheduled first, right? Because the priority was same, and the thread scheduler randomly picked up the threads out of 2 and scheduled second prior to the first. Okay, right. So moving to the next one, right? We are only left with a very little amount of lecture. So I really salute your patience that you are, listening this function or listening this lecture for very first time, right? Okay, so the synchronized block in Java. So over here, what is the problem with synchronized method, right? See, uh, if so in synchronized method, we have actually made the whole method synchronized, right? But the situation might be different in a different scenario, right? In a whole method, I only want to synchronize some of the lines, but not all the lines, right? So I can actually I can, so despite of synchronizing whole function at one shot, I can only and only synchronize those specific selective lines, right? So this is all about synchronized block, right? So so here, this is the theory, right? What is actually a synchronized block, right? So suppose you have 50 lines of code in your method, but you want to synchronize only 5. So you can use synchronized block, right? So if you put all the codes or all the lines of the method in a synchronized block, it will work same as the synchronized method, right? So there is no need to, so there is no use to make use of a synchronized block, right? So synchronized block is used to log the specific shared resource or the specific lines of code, right? And the scope of the synchronized block is always smaller than the synchronized method, right? Okay, so in this scenario, right, there is a slight difference between the previous codes, right? So first of all, I'm just going to copy this code and paste into the IDE my of my Eclipse, right? And over here, I will show you that how this method actually works, right? Okay, so everything is same, right? So we do have a test class, we do have a main function, right? We have created the object code of the table. We have created the two threads, right? We passed this object to both of the threads, right? We triggered both of the threads, right? And now these are the changes, right? Please pay an attention over here. So in the class table, right, previously we written this synchronized keyword over here, right? But now we have written this synchronized uh, uh, keyword inside the function, right? And we've written this keyword, right, because we want to tell interpreter that uh, this whole piece of code is actually related to this class, right? So what I did over here, I only and only blocked this line, this much lines of code. I mean to say that in this scenario, I have not made whole function synchronized, but only and only for loop that is actually located inside that particular function, right? So this is the change only, right? And the rest of the code is actually quite same, right? So here, both of the threads actually sending some integer number, right? And they are sending their names, right? To the print table, right? So that we can examine the output of both threads clearly into the console, right? So I'm just going to run this code so that we can observe, right? So this is the result. Okay, so according to the parameters sent by both of the threads, right, it has computed, right? So this time the thread scheduler has scheduled thread 1 prior to the thread 2, right? So while the thread 1 was running on this synchronized block, the thread 2 was actually waiting for thread 1 to get terminated, right? And once thread 1 got terminated, the thread 2 began its task, and eventually it also got terminated by completing its task. So this is all about the synchronized block of the synchronization in Java, right? So this is again the same example. I mean, the exactly same example of the synchronized block, but with the anonymous class, right? So you can simply, I mean, copy and paste this code inside your favorite preferred IDE, and you can run this code, right? So you now know that what is anonymous class, and you are, and you know, I mean, that what I might have did into this piece of code, right? So okay, so over here, please change the name of this thread, right, into this anonymous class, because I mistakenly written thread 1 in case of both of the threads, right? So okay, so this was the last concept of your static synchronization, or your synchronization. So what is static synchronization? So sometimes we do have more than two objects, right? Um, we have to share more than two. Sorry. Sometimes in some scenarios, we have to share more than one object at the same time, right? And assume that at the same time we have triggered more than two threads, or for an example, multiple threads, right? So as this diagram vividly demonstrates the situation, right? So here, this diagram actually explains the working of a synchronized method and synchronized block way of synchronization in Java. But there's a catch. There is a problem in this diagram. This is what we need, the static synchronization, right? Okay, over here, the object 1 was actually shared with T1 and T2. So the object 1 was synchronized, right? And similarly, the object 2 was shared with T3 and T4. So the object 2 is synchronized, right? So object 2 is only and only synchronized with T3 and T4, whereas object 1 is only and only synchronized with T1 and T2. Now there's a problem, right? as far as the working of T1 with T2 is concerned, everything will work smoothly. And as far as working of T3 with T4 is concerned, everything will work very very smoothly, right? But now the problem will occur if for an example T3 is working on object 2. Yes, at this time T4 is waiting because T3 is working, but now T1 has accessed object 2, right? And object 2 is not synchronized with T1. Now, at that time, T1 and T3 both will work on object 2 at the same time, right? So T3 cannot prevent T1 to work on object 2 while it is working, right? T3 does not have an authorization or power to stop T1 to work on object 2, right? So this is the main problem why we need static synchronization, right? So these lines exactly explaining same about the synchronization, right? So suppose there are two objects of a shared class, right? Example table that we did in the previous examples, right? Name object one and object two. So for an example, we made two objects, object one and object two of the table class. In case of synchronized method or synchronized block, there cannot be interference between T1 and T2 or T3 and T4 because T1 and T2 both refers to a common object that have a single lock. But there can be an interference between T1 and T3 or T2 and T4 because T1 acquires another lock and T3 acquires another lock. I mean to say that there is no communication or notification between T1 and T3 because both are working on quite different objects, right? We want no interference between T1 and T3 or vice versa, like T2 or T4. So this is why we need static synchronization, and static synchronization solve this problem, right? So this is I think the last piece of code that I need to explain to you, right? So after that, the synchronization process of the Java will come to an end, right? So in this example, we are actually applying the synchronized keyword on the static method to perform the static synchronization, right? So I'm just copying and pasting this code into the IDE, and I will explain this code thoroughly to you, right? Okay, here we are, and now let us start with the main class or the parent thread or the parent class of that is actually a test class. We do have a parent function or the main function, right? And in that function, we created 4 threads, right? We triggered all the threads at the same time, right? Okay, so how we applied the static synchronization, right? So let us have a look on that. Let us have a gaze on that. Okay, so here we are. So there's a class table, and here we do have a shared function that is print table. So as you can clearly see that we do have the 4 classes for the 4 distinct threads, right? And every thread has its own engine public void run, and every public void run of every specific thread actually calling the same function, right? Or the same function is actually shared among all the 4 threads, right? And every thread is actually sending some parameters, right, while calling the same function. Like the first thread is actually sending 10 and its name, second is sending 20 and its name, and so on till the 4th thread, right? So where's the change, right? So change is over here, right? Change is over here, right? So we have written the synchronize, and at the same time we have written static, right? So we have written synchronized static. In the previous examples, we have only written synchronized with the print table, right? But we have not written the synchronized static, but now this time we mentioned synchronized static, right? So now the print table is now statically synchronized between all the threads, right? Those are actually attacking on the same table, on the same function of the table class, right? So now let us run this code and examine the output. Okay, so this is thread 1. Okay, thread 4, thread 3, and thread 2. Right. Okay, fine. So the thread scheduler has in our scenario scheduled thread 1 prior to each and every thread, then thread 4, then thread 3, and at last at thread 2. And every thread turn by turn, right, did their work, and eventually they terminated, right? And every thread have taken their own numbers, and numbers were actually multiplied by the iteration of the for loop, and eventually we can able to see the result of each and every step or each and every thread, right? So all the I'm so sorry, all the threads were actually statically synchronized, right? So every other thread was actually waiting for the previous thread to get terminated so that it could resume its work, right? So our synchronization has worked very nicely, right? So this is all about the static synchronization, right? And also I did a slight change over here, right? See, in the previous examples, we created an object of the class table in the main function of our parent class, right? But over here, in case of static synchronization, right, our table class contains already a static function, right? So if you remember that if any class contains a static method, then there is no need to create an object of that particular class to access that particular function, right? So this is why we have not made any object of the table, right? You can see nowhere in the code we have not created any kind of tables object, right? Instead we have directly called the print table function by making use of the dot operator with the table class. And how is it made possible? Because we made the print table function static, right? And if we make any of the function of any of the class static, so in order to get an access to that function, we do not have to make an object of that particular class. We can directly get an access to that class by simply specifying the name of the class with the dot operator and followed by the name of the table, right? So this is all about today's lecture, right? And I hope everything is explained in very detailed, right, to all of you. And I hope that everything is actually quite clear in all of yours mind, right? So till now, if you do have any kind of question or query, you can discuss with me, as we do have 13 more minutes to finish the lecture. Yes, students, I'm done with my lecture. Do you have any query? I Hello, is anybody listening? Seems like another scenario, I think. Okay, right, Akshat. Thanks for your reply. Okay, so Akshat, is everything clear to you? Okay, that's nice. I'm delighted. Do you have any query regarding yesterday's lecture? Okay, right. Thanks for replying. And yes, anybody else? Do you have any query regarding yesterday's or today's lecture? I'll be more than happy to answer your questions. That this is really very important topic while programming the multi-threading in Java, right? So when you will be a developer in some company, right? So you have to go through these all kind of steps, right? While while implementing the multi-threading, right? So I actually made you understand, and I actually delivered this lecture in such a way that each and everything should be clear to you in a more practical or development point of view, right? Okay, so I think as nobody's replying or nobody's is asking any kind of question, so I'm really very happy that everything is clear to each and every one, right? And this is really a very good sign for me. Okay, so I will share this content. Wait a second, I'm going to share this content over here, right? So I'm just going to drag and drop this Microsoft Word file with you over here, right? And yeah, okay. So you can refer to this file for theory and the various codes that we have gone through already in today's lecture, right? And you can try these all kind of things by your own. And if you think that you came across any kind of query or any kind of doubt, do write the queries and questions on a blank paper, right? And I'll be more than happy to clear your queries into the next session. Okay, so I advise you to leave the meeting only after 9 minutes, right? So our class is coming to an end in next 8 to 9 minutes. So you can leave this meeting in next 8 to 9 minutes. So I want a feedback. Do you have any kind of problem with the lecture delivery? I mean, should I change my talking speed, or I mean, or is everything good? I'll be very happy to receive the feedback about the lecture from you people. Thank you. Okay, so I'm done with this lecture, right? And we will meet exactly at 12 p.m. for another 1 hour, right, for your discussion session. and I'll give you some problems, right, on today's topic, and you can discuss with me about the problems that I gave you yesterday, right? So I'm just going to mute my mic, right, and we will finish this lecture in next 5 to 6 minutes.